Unit set on cooling. Turn the fan on. Doesn't do anything. There's the air handler. Let's open it up, see what's going on. All right, we got 241 volts. Checking the main power coming in. Let's check from our R to RC. See if we got 24 volts. No voltage. Okay, so now we need to check the transformer. Power coming in, power going out. All right, got my meter hooked up to the primary side of the transformer. You can see those two wires went to the primary. Gonna turn the breakers back on. Okay, so we got 240 going to the transformer. Now I'm gonna check the secondary. Checking the secondary, I've got 0 volts. You can see that we're on the 24 volt side there. No voltage. Bad transformer. Got to replace the transformer. Bad transformer. Kind of looks a little black underneath that plastic. I need to see what caused it. Is the board burnt at all? It doesn't look like it. Fuse is not blown. Let me go outside and check the condenser.
You have a bad transformer, that means there is a cause. Usually there is a cause. So what I'm doing is I'm trying to find the cause, because the effect was the transformer is now bad. Let me show you what I'm looking for. Come outside. I don't know which condenser it is. These are the two closest to that apartment. These are a bunch of apartments, so I'm just going to open them both up and check them. This right here could definitely be the cause. Oh, you hear that? Heard a little click. Since we heard a click for those thermostat wires over here, this one is the one that goes to that apartment 20. How do I know that? By the way, that's not my Coke. Somebody put that on the unit. Sorry about your Coke, sir. Don't leave it on the unit. So this one's the one because the power's off to the indoor unit and no longer providing 24 volts out here. So since there's power on that wire still, this can't be the unit. This has got to be the unit. So I'm going to do some further investigation, but this is probably the cause right here. These wires that were rubbing, just got to make sure that you know what the wires go to and just have a good logic behind your process. Make sure there's a fuse in line on your secondary side of your transformer. That way, when you put the new transformer in, if you do have a short still, then it'll blow the fuse instead of blowing the transformer, okay? So make sure that you have a fuse in line. Here's my new transformer, and you can see that I'm going to be using, since this is 230 volt, I won't use the black or the red wire. I'll use the white and the orange wire, and then my secondary is the red and green. So I will be using this white wire here and this orange wire since it's 230 volt. Okay, so this will be my primary coming into the transformer here. Okay, and then this right here, these two wires on the other side will be my secondary. So make sure you get some wire nuts. All right. Make sure you get some spades. I put a spade on my secondary R wire coming from my transformer using my crimping tool. Make sure you have a crimping tool. All right. Now I'll mount it in and wire it up. Could not get my drill and my extension up here because of the door frame, but no big deal. Boom. Got the transformer mounted, inline fuse. So, got a step stool. Beautiful. Fuse popped immediately. All right, now I'm going to unhook a couple wires and do a process of elimination. Found another splice right here. Anytime you got a fuse blown, transformer blown, you put the new transformer in, you need to do a process of elimination. So I can take the wires off out here, put the fuse back in, see if the fuse blows. If it doesn't blow, then I know it's inside the condenser. Okay, if it does blow, then I know that it's not in the condenser. It's in the stat wire or it could be somewhere else. Make sure you pay attention to the wires and the way they go together. So, all right, that right there is all not touching. Let's go get another fuse, put it back in. All right, so I took out the fuse and now I've got my little 2 amp resettable. Anytime you're trying to find a short, you don't want to be blowing fuses one after the other. So got my little resettable. You can find those on equipment that you take out and that you change out. Oh, and it's on. So it looks like the problem's in the condenser. All right. So the fuse did not blow whenever I took the thermostat wires loose from the outdoor unit. So I isolated the outdoor unit, turned the power back on to the air handler inside, that 230 volt air handler, because this is a heat pump unit, heat pump split system. And now the fuse doesn't blow. So I know for sure it's in the outdoor unit, but where could it be? Well, it could be in the coils. There's a reversing valve coil, there's a contactor coil. I'll check the coils visibly. I will smell and see if there's any burnt smells, and then where it's most likely at is a wire touching. 90% of the time it's in a wire touching. So, especially when it's a 24 volt short. So I got the whole top off the unit. And what am I gonna do? I am going to cut every zip tie where there is a wire. And I'm gonna find that short. And when I find that short, because I've already looked at the coil, contactor coil's right there, you can see. Doesn't look burnt. We got that coil there. We got our thermostat wire with this splice. That could be it. But we got a bunch of wire touchings. We've got a bunch of wires touching, and I'm gonna cut those wire ties off and see which one it is. Okay, so I got all the wires back together out there, moved every wire around. Oh, still got a problem. So it could likely be in the thermostat wire since I didn't find anything in the condenser. Kevin, how far did you drive to see me?
4 hours.
4 hours, and I'm helping you do what?
Change out my transformer and diagnose a low voltage short.
So I'm helping you fix your air conditioner. And it just happens that Kevin, our schedules, it's hard to meet up because, you know, he's driving 4 hours from where? Clinton, Tennessee, okay. And I'm working right now, but the job that I'm working on, it's funny because it's a low voltage short. Mm-hmm. So it's like interesting, and it's like, it's actually good. It's like works out perfectly.
It couldn't have been a better situation.
Yeah, because I'm able to give him some advice before he heads back. But if you had any advice for anybody out there that's on the line about joining my YouTube channel as a member, becoming a client, what would you tell them?
Take it from me, learn from somebody who knows what they're talking about, and that's Mr. Taddy here.
Boom.
Sure.
All right, cool. Thank you very much, Kevin.
Thanks, buddy.
Let me show you where I'm at. So I had this bundle of wires. I cut that out. I want to make sure that's not the issue. Went inside, turned the power back on, fuse was blown, okay? Come back out, I take my wire off my reversing valve coil, and I take a wire off my contactor coil. Go back in, turn it back on, fuse doesn't blow. So I know for sure, without a doubt, it's either that contactor coil that's causing the short or that reversing valve coil. So I'm gonna do the reversing valve coil first. Put this back on, go back inside, turn the breaker back on. Let's see if it blows. If it does, it was the reversing valve coil. If it doesn't, I'm gonna put that wire on, turn it back on. It's the contactor coil. Let's go. Contactor coil is the only thing isolated right now. So if this fuse blows, then it's the reversing valve coil. And if it doesn't, then we know it's the contactor coil. Boom. It's the reversing valve coil. All right, I'm gonna unplug the reversing valve coil, plug in my contactor coil, and then we know for sure what the problem is. This right here is the coil that is likely shorted. We're gonna take the wires back off. We are going to take the wire for the contactor coil, which was right here, and put it back on. All right, now we should be able to turn the breaker on, and we should not have a blown fuse. All right, so I'll just get a new coil for this reversing valve. Oh, by the way, check all the wires that go to the reversing valve coil. I checked all of them. There's nothing rubbing, nothing touching. Moment of truth. Did we find the short? We found the short.
It's in the reversing valve coil. All right.
Cause and effect. This was the cause that affected the transformer. So I do not have one of these. I'll have to order it. It's super cheap and it probably won't take long to get it. Maybe a couple days. I'll be back, put it on, and the customer will have air conditioning. If you do not know how to find a low voltage short, check out my playlist, HVAC Tips for Technicians. I've got a video on how to find a low voltage short that talks about the process of elimination and how to look at it in a simpler way so that you don't get overwhelmed. You take your time and you isolate different parts and then you find the issue. Thanks for watching.
Right now I'm going to show you the resistance readings of the old bad reversing valve coil that we're replacing and the new reversing valve coil. I'm going to show you the difference. There's definitely a difference. So you can tell it's bad from the reading. What is it? Come on, stay still here. 0.4. All right, now what we should have is around 16. So 16. Now I also have another reversing valve coil that's good. I'm going to show you this so that you can compare here. All right. Remember to set your meter to ohms and 16. All right, let's go install this. All right, so check out my dilemma. This one fits right on where you can tighten the nut down right there, right? And this one doesn't go all the way on. Great. So I gotta fix this and I know how. I hope I know how. I'm gonna open it up right here. Because yeah, it won't go on. I gotta open it up so it'll fit on there. And I know how I'm gonna do it. I got my unibit and I'm gonna drill this hole out a little bit. All right, now take a look at it. Let's see if it fits now. Beautiful. Can I screw the nut on though? Barely. All right, I got something else for that. Got to make it work. All right, get my little snips. I'm gonna shave just the edge of this off. I should be able to cut this, I think. All right. Beautiful. Awesome. That is fantastic. Okay. Oh, yes. So excited. What is this wire they've got attached? You hear that? That's beautiful. That's what we want to hear. Awesome. Sometimes you got to make it work. Got a uni bit and made the hole to where it would fit on the reversing valve. And now we're going to have air conditioning. Some technicians would order a new reversing valve coil. They would say, this one's not the right one, but that's the one that they sent. So I made it work. Make it work. Gauge is hooked up, got my temperature clamp on my vapor line. Beautiful. I love it when it works. So reversing valve should energize in the cooling operation. So we've got 24 volts to that coil. I'm gonna check the pressures and we're gonna be in good shape. Suction pressure is 75, head pressure is about 265, 270. So suction pressure looks pretty good. Head pressure, it looks pretty good. A little bit high, maybe. Vapor line temperature 73. Yeah, that's definitely got to come down, but it's getting cold. Yay. Hope you enjoyed today's video. I hope you learned something. Let me know in the comments what you learned. And if you don't have any questions, tell me who you are. Tell me where you're from. Really appreciate you watching. Hit the like button, subscribe, and hit that bell before you leave. And if you need help with your project, you need tech support, click the join button, become a member. Let me know in the comments, say I joined, and I'll give you my email. If you want my phone number, become a level 4 member. If
If you want one-on-one consultation, level 5. You've been watching HVAC Tips for Technicians. I'm Tad, and I'll keep you cool if you let me.